Homework 4 is about solving for the variable, regular non-quadratic equations. Of course, what you need to do in this sort of situation is isolate the variable, and then whatever number you have on the other side is your answer. Since this is an m over here in question number 1, first thing you got to get rid of is this other term, so subtract 17 from each side. So you've got 3m equals 77 minus 17, which is 60. Then you need to get rid of the 3, which is being multiplied by the m. So we can divide each side by 3 in order to cancel that. And you have m equals 20. The second one's a little more complex, but the first thing you need to do is multiply it out to get rid of the parentheses. So distribute the 2 times x minus 1. So 2 times x and 2 times negative 1. So 2 times x is 2x minus 2 plus 3 equals x, and then we can distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. When you have situations like this, the first thing you want to do is combine what you can combine. So on the left side, for example, we can say 2x, and then combine the negative 2 and the positive 3 into positive 1. And on the left side, we can do negative 3, x minus 3x, which is negative 2x, minus 3. Now we've got letters on one side. We want to try to get letters on one side and numbers on the other. So we can move the x's to the left side and the numbers to the right side, or vice versa. It really doesn't matter. But let's try to keep things positive, so to speak. Yuck, yuck. By adding 2x to this side to get rid of this term, add 2x to this side to get rid of this term, and now we've got 4x on this side. And as far as the 1, we can subtract 1 to get rid of it from this side, so we can subtract 1 from this side as well. You can do anything you want to one side of an equation as long as you do the same thing to the other. Negative 3 minus 1 is negative 4. Now we can simply isolate the x by dividing each side by 4. Remember, this is 4 times x, so divide by 4 cancels it. And we've got x equals negative 4 divided by positive 4, which is negative 1. Number 3 is a little bit of a crazy one that's really designed to just give you some practice. I'm not going to give you something this complicated on an exam, but it gives you a lot of practice of opening up expressions and manipulating algebraic expressions. Here we've got some brackets, which actually is what you do when you have a parentheses outside of the parentheses. In this situation, you want to work from the innermost parentheses outwards. So you want to try to open up the inner parentheses if you can. So let's start by opening up these inner parentheses over here. Negative 3 times y plus 2. So this becomes negative 3y, because negative 3 times y is negative 3y. Then negative 3 times positive 2 is negative 6. Let's open up this parentheses over here, again trying to get rid of the brackets. So the 5 times y minus 1 becomes 5 times y minus 5 times 1, which is 5. So let's take a look now at trying to write it over with these things open at least. We've got the 25 still. We've got the minus. Now we can use parentheses instead of brackets, since we now just have the 2y plus 5y minus 3y minus 6 equals, and while we're at it, let's open up this one here. So negative 3 minus, negative 3 times 2y is negative 6y. Negative 3 times negative 5 is positive 15. And then subtract this entire parentheses. 5y minus 5 minus 3y plus 3. All right. Let's combine what we can combine to start with. Let's work with the parentheses first, again with PEMDAS, with the order of operations. Let's work within the parentheses first. So let's keep the 25 where it is. 2 and negative 6 combine to negative 4. 5y minus 3y combines to positive 2y. See, getting a lot more manageable now. And on this side, we've got negative 6y plus 15 minus, and the 5y minus 3y becomes positive 2y. And the negative 5 positive 3 becomes negative 2. Now we got to open up the parentheses over here. And the way to open up parentheses that are being minused, you don't actually have to subtract, you don't have to actually multiply anything. So the way to open up the parentheses that are being subtracted is just change all the signs in the interior. So it's 25 minus negative 4, which means positive 4, minus positive 2y, which is minus 2y, equals, on this side, we've got negative 6y plus 15, which we haven't touched in a while, that's fine, minus 2y, minus negative 2, which is positive 2. Okay, now let's combine whatever we can combine. 25 plus 4 we can combine into 29. We have to leave the 2y by itself. On this side we've got negative 6y and negative 2y becomes negative 8y, and the 15 and the 2 becomes positive 17. Now we want letters on one side, numbers on the other. Let's try letters on the left, numbers on the right, although it will work just as easily on the other side. So we want to get rid of this whole term, and the way to get rid of this whole term is to add 8y to this side. Whatever you do to this side, you got to do to the other side too. And subtract this entire term, minus 29, minus 29. And now you're going to have numbers on the right, letters on the left. Negative 2 plus 8y, negative 2y plus 8y is positive 6y, equals 17 minus 29, which is negative 12. And now you just simply need to isolate the y by dividing each side by 6. And you have y equals a relatively simplistic negative 2. Again, this is just some practice to get used to the idea of manipulating algebraic expressions, but hopefully you won't see something quite this complex on an exam. Number 4 is a problem that has denominators, which whenever you're solving an equation, the first thing you want to try to do is get rid of denominators. Denominators are very hard to work with. Now, the way you can get rid of denominators is by multiplying each term by something that is going to cancel out the denominator. And in order to do that, you need to find what is called the LCD, or the least common denominator. Now, in this case, you can do a little bit of trial and error. What goes into 8, 4, and 6? Well, 16 goes into 8 and 4, but not 6. 12 goes into 6 and 4, but not 8. So if you do a little trial and error, you'll realize that the least common denominator in this case is 24, which goes into 4, 8, and 6. So you can multiply each term by 24. So remember, you can do anything you want to one term as long as you do it to the other terms as well. That's the great thing about algebra. So you've got this term, 24 times this. Then you've got 24 times 3 over 8 plus 24 times x minus 5 divided by 4. Okay, so now we can start canceling, and these are all going to cancel. 24 divided by 6 is 4, so you can cancel this, make this into a 1, which gets rid of the denominator, and make this into a 4. Over here, 24 divided by 8 is 3, so this becomes a 3, and that gets canceled. And over here, this becomes a 6, and that becomes a 1 because 24 divided by 4 is 6. So what you're left over here, everything else is canceled except 4 times x plus 3. Don't write 4x plus 3 because it's 4 times the entire term. It's 4 times the entire x plus 3. This next term, you've only got 3 times 3 left, which is simply 9. Plus, and now you've got 6 times the entire x minus 5. And from here, open up the parentheses and solve like we did before. Distribute the 4, which is 4x plus 12, equals 9, plus 6 times x, 6x, 6 times negative 5, negative 30, and combine what you can combine. So you've got 4x plus 12 equals 9 minus 30, which is negative 21, plus 6x. And so now we can again move the numbers to one side, letters to the other. Historically, we've always been doing letters to the left. And then we can move the number to the right. So you got 4x minus 6x is negative 2x equals negative 33. Divide each side by negative 2 to isolate the x. And what you have is x equals positive, because it's a negative divided by a negative, 33 over 2, or you can write it as 16.5, which is 33 divided by 2. Number 5 is a similar problem to the one that we've looked at before, much easier than number 3, and really all you need to do with the first step over here is open up the parentheses to start. So we can leave the 8x as it is. Now this becomes negative everything in the parentheses. So negative 3x, negative positive 2 is negative 2, plus 10 equals 3x, okay? Combine what you can combine, 8x minus 3x, 5x, negative 2 plus 10, positive 8 equals 3x. Now we want the letters on one side, numbers on the other. We've already got the numbers on this side, so maybe we can get rid of this term to get the letters on the other side. So subtract 5x from this side too. And we've got 8 equals 3x minus 5x, which is negative 2x. To isolate the x, we can divide each side by negative 2. And we've got x equals 8 divided by 2, which is negative 4. Obviously, it makes no difference whether the x is on the left or the right. Number 6 is a word problem. And in preparation for number 7, which is a little bit of a harder word problem, what I always recommend with word problems is to start with what's called a let's statement. And a let's statement tells you, it defines what your variable is. Now, in this case, what we're looking for is a number. So all we have to say is let x, let's say, for example, equal the number. Now, it may seem irrelevant or unnecessary in this case, and it probably is, but it's a lot easier when you've defined your term and when the problems get a little harder. So let's look at how this works in algebra. 3 times a number, well, we know that x is the number, and 3 times the number is 3 times x, which is 3x, decreased by 22, which means subtract 22, that's what decrease means, is, which always means equals, 5. Find the number. Let's solve this. This obviously is very simple. Isolate the 3x by taking the 22 out. So we've got 3x equals 5 plus 22, which is 27. Isolate the x by dividing each side by 3, and you've got x equals 9. And that's our number. Number 7 is a little bit of a more complicated word problem. Here you're choosing between two health clubs. Club A has a higher membership fee, but a lower monthly fee, and Club B has a lower membership fee, but a higher monthly fee. $40.25 monthly versus $15 to sign up and $30 altogether, and then they want to know, or we want to know, how many months will the total cost of each club be the same? And then what will be the total cost for each club? Now, we know the monthly cost. We know the upfront costs. What don't we know? The only thing we don't know that we need to solve this problem is the number of months. So that's why let statements are important, because we have to define them properly. So let's say let x be the number of months. That's the only variable, if you think about it, that we really don't know over here. So let's try to figure out cost A, or the cost of Club A cost, and equal that, because we want them to be the same, equal Club B cost. So let's put two sides of the equal sign, and let's try to put the Club A cost over here, and the Club B cost over here. So for Club A, we know it's a membership fee of $40, plus every month it's $25. So it's 25 times the number of months, which is 25 times x. Club B starts with 15 and adds how much for each month? 30. So it's 30 times x. You see why that works? Because x is the number of months. So it's 25 times the number of months for Club A, and 30 times the number of months for Club B. Once you have that, now it's a very simple equation to solve. Let's say, get rid of the x term from this side, and do negative 30x, and the number term from the other. Just because we've always been doing letters on the left, numbers on the right. So 25 minus 30x is negative 5x. 15 minus 40 is negative 25. isolate x by dividing by -5, divide by -5, and you've got x equals -25 divided by -5, which is +5. So what is this? Okay, so we've got 5. Well, our let statement told us that x is the number of months. So that means the answer to our first question is 5 months. What's the second question? What's the total cost for each club? Well, let's see. They should be the same. Let's figure it out. This is 5 months. So for club A, we've got 40 plus 25 times 5. 40 was the startup fee, and 25 each month. 25 times 5 is 125, plus 40 is 165. And for club B, this had better be 65 also. 15 plus 30x, 15 plus 30 times 5. Well, 30 times 5 is 150, plus 15 is also 165. Very good. Okay, our last problem over here is also a least common denominator problem. And the good news is you've only got two denominators and they're the same. They're x minus 2. So if you multiply everything by x minus 2, you're going to get to cancel all the denominators. So our LCD is just simply x minus 2. So let's do x minus 2 times 2 over x minus 2 equals, again, x minus 2 times x divided by x minus 2. And you have to do it to the last problem also. So that's 2 times x minus 2. Everything's got to be multiplied by x minus 2. So of course this cancels with this. Same term, this cancels with this. And what you have left over is just a 2 over here on the far left equals x is the only thing that's left on this term, minus 2 times x minus 2. Now we can open the parentheses to get you 2 equals x, minus 2 times x is negative 2x, negative 2 times negative 2 is positive 4. So we've got 2 equals x minus 2x, which is negative 1x, plus 4. Subtract 4 in order to isolate the x. So we've got negative 2 equals negative x, and we can multiply or divide each by negative 1 in order to get rid of the negative x. Just flip the signs, and you have x equals positive 2. That would be your answer. The problem is, as I discussed in the original expression, is that if you try to check it, if you take one look at it, you'll see that this is not possible, because the denominators would be 0. The denominators here, x minus 2 and x minus 2, would be 2 minus 2 would be 0. And because this does not check, because that would be an undefined check, there is no answer. So the actual answer to this question is that there is no answer. It's a null set. But if you solved it properly, it would be negative 2, but that's sometimes why you got to check it to make sure that there are no zeros in denominators, because zeros in denominators cannot exist. They're undefined.